Today, you can do almost anything in a browser. Write documents, create spreadsheets, play games, navigate virtual streetscapes, even experience 3D graphics. It's easy to forget that when the web became a mass market phenomenon in the mid 1990s, it consisted mostly of static pages with text and graphics. This module tries to illuminate the two main trajectories of the 25-year journey that led from static pages to microservices and RESTful APIs, or application programming interfaces. The first trajectory is an intellectual one. To oversimplify just a little, developers stopped thinking about the web as a collection of pages delivered to a universal viewer and started thinking about it as a collection of programs that could be invoked remotely to return any kind of data, not just a viewable web page. In other words, the infrastructure of the web came to be viewed as a possible medium for remote procedure call, in which a web client essentially calls a function that gets executed on some other computer, which eventually returns an answer. That insight transformed the web into a mesh of services. But the basic idea of remote procedure call had been explored much earlier. You see, once you start thinking about calling a function on another computer, you have to solve all kinds of problems, such as how do you pass arguments and get a result? What happens if something goes wrong during execution on the remote computer? What if the remote computer crashes or is unreachable? These issues and others were explored in a classic 1984 paper by Andrew Burrell and Bruce Nelson, researchers at the Xerox Palo Alto Research Center, or Xerox PARC, where many of the technologies underpinning personal computing were first invented. The second trajectory has to do with standards adoption and holds some valuable lessons for technologists. The original Hypertext Transfer Protocol, or HTTP, was never designed to support remote procedure call. In fact, it wasn't even designed to support the concept of a web session, such as remembering whether you're logged in or not. But by the time people were thinking about how the web could go beyond static content, HTTP and the other related web standards were already too entrenched. So instead, the standards had to be evolved and adapted to the new needs, such as by inventing new HTTP headers for cookies to remember if you're logged in, or for caching to speed up delivery of frequently requested content. Just like the QWERTY keyboard layout, HTTP was simple enough that it spread very quickly and good enough that it would be too difficult to displace. Similarly, RESTful APIs have become the de facto standard for communication among web services, but rather than being created as a prescriptive standard, REST codifies some of the best practices that were learned the hard way over the 2 decades during which the web evolved. In contrast, you could make an acronym soup out of the many failed attempts to establish other standards for inter-service communication, including SOAP, CORBA, UDDI, DCOM, XML-RPC, and many others. Some of these standards were carefully thought out and may have been technically superior to REST, but critically, REST was simple to understand, it worked well with existing protocols and tools that were already deployed, and it was good enough to build on. Indeed, this historical lesson repeats the experience of developing TCP/IP, the universal communication protocol underlying the entire internet. The winner is most likely to be a simple solution that's easy for developers to understand and work with, works well with existing deployed software, and doesn't require individual developers to make licensing arrangements to use it. So, as you learn about service-oriented architecture, microservices, resources, and RESTful APIs, keep in mind that these so-called standards are really recommendations based on years of experience using and extending simple protocols that were good enough not to be displaced.